is the distribution of hotels in the map, and it's used the volume library. Areas with the highest density are marked in red, and the areas with the lowest density are marked in blue. We can see from the heat map, the hotels are mainly distributed in the central and the northeast areas of New York, and with the few scattered in the southwest, fewer listings on Staten Island, and hotels are primarily located in Brooklyn, Manhattan, Queens, and the Bronx. You can see that the pie chart and bar chart are used to show the share of listings in each neighborhood group using the Matplotlib and Sanborn libraries. After analyzing nearly 49,000 observations, it can be inferred that Manhattan had the highest share of hotels and Staten Island had the lowest share of the hotels. This scatter plot shows the distribution of prices using the Matplotlib, and the red dot represent more expensive apartments or rooms, and blue dots represent less expensive apartments or rooms. And we can see that Manhattan and Brooklyn have more expensive apartments. Violin diagram shows that Manhattan has the highest prices, with an average price of about $125, followed by Brooklyn and Staten Island. The map uses volume library to filter the top 100 listings based on the number of reviews, showing the most popular listings. You can slide your mouse to zoom in or out of the map and click on the number of reviews in the map to go to more specific listing locations. And we can see that listings in Manhattan and Brooklyn are more popular and in line with the urban characteristics of them. There are 4 tab panels that allow filtering and the selection of room type, neighborhood group, price, and number of reviews. And in the neighborhood group panel, we can click on the legend for Brooklyn, and the Brooklyn area in the scatter plot turns green. In the toolbar, we can select box room and zoom in on a more specific selection. And we can also click Reset to restore the original state. And you can click Pen and drag it around. In the price panel, as we can see from the chart, the listings priced between $300 and $500 are mainly distributed in Manhattan and Brooklyn. As we can see from the parallel coordinate plot, the yellow lines represent shared room, the green lines represent entire room, and khaki lines represent private room. It shows that shared rooms are more popular because they are cheaper and require a smaller minimum number of nights. The parallel coordinate plot is highly interactive. You can drag the lines along the axis to filter regions. And you can also drag the names of the axes across the plot to reorder the variables. Bar chart and pie chart were created using the Matplotlib library, showing the top 10 communities with the highest number of rooms. The charts show that Williamsburg has the highest number of rooms of any community, which is 8%, while Midtown has the lowest number of rooms, which is 3.2%. This word cloud shows that the most commonly used words in listing names using word cloud and the collections libraries. We can see that the images of apartments, private rooms, Manhattan and Brooklyn are larger, indicates that they appear more frequently in room names. This bar chart shows that top 25 most commonly used words in listing names using the Seaborn Library. A clear trend can be seen where hosts are simply describing their listings with very specific and catchy terms such as room, bedroom, private, apartment are used more often in the names of listings. The bar chart shows that top 10 hosts with the most listings in New York City using the Seaborn Library. It can be seen that hosts with host IDs 2195-17861 and 1074-34423 have the most listings, with 327 and 232 listings, respectively. A scatter plot of actual and predicted prices is plotted, which gives a better visualization of the arrow between actual and predicted prices. It can be clearly seen that there is an arrow between the actual and the predicted price. However, with a MAPE value of about 29%, the model can still be classified as a reasonable prediction. To confirm the effect of geographic location on price, let's use the optimal model SGBoost to find the important features or dimensions in the dataset that have the greatest impact on house prices. It can be seen that room type and location are the most important features, which is in line with real-life scenarios where room type and location greatly affect the price of the listing.